Hello, and we are back. So today I want to start a new series, and we're going to move around a little bit. So change, I'm still trying to figure out the best format. So rather than plowing through an entire paper, we're going to kind of jump around to some of the bits that are relevant, because what I want to talk about is some of the work in AI safety. Um, and specifically, I want to kind of lead this up to the work of, so I can basically gush about Dr. Ling Shi and how awesome she is, and some of her awesome work. But, I sort of, one, trying to read some of her work is challenging, to say the least. But then also, it's right at the forefront of like multiple fields. Um, uh, yeah, like we'll come to it. But then uh, she also is built on a lot of other stuff. So rather than just jump straight in and say, "Hey, let's look at some of the most sophisticated advances in AI," let's sort of roll back to sort of introduce some of the work that was happening in the sort of 2020s, 2030s that then she built on. Her PhD was in AI safety research, and specifically natural language debate models. So, and the beginning of this kind of work started with a paper by OpenAI uh, called AI Safety via Debate, which had three authors, Jeffrey Irving, Paul Cristiano, and Dario Amodi. And rather than because it's a long, it's mostly a theory paper. Let's see how many, we can have a quick look. Yeah, that's like a 24-page deep dive. They go into theory. They compare it to adversarial testing. They do all sorts of things, right? And it's quite a technical paper. So, but instead, what I'm going to do is I'm going to pull out the key threads. So let's jump around it a little bit, and then say, hey, look, here are some of the recommendations they made, and this is what she did in her PhD, and then that led to some pretty significant advances in what we thought was better AI safety. What we thought was better AI safety, at least. And before then, we can jump forward to her explosion of publications across multiple different fields. I met her once at a conference, and incredible person, full of energy. It's like 5 foot nothing. Was always on little platform trainers, Chinese, massive curly hair, which is unusual, and just like a little ball of energy, bouncing around and chatting to everyone, and always smiling. Amazing person. Which is why, yeah, we'll come to what's happened to her afterwards. So, but yeah, really want to support her. So, anyway. Let's get going. So, AI safety via debate. Okay, let's just jump in on the abstract, and we'll keep going from there. So, to make AI systems broadly useful for challenging real-world tasks, we need them to learn complex human goals and preferences. Yep, sure. Remember, this is 2020s, 2025, I think, when this was originally published. So, they're still at the days. They're still in the days where they're so optimistic, right? And they're so we can do this. We can make AI safe, right? One approach to specifying complex goals asks humans to judge during training which agent behaviors are safe and useful. So this is like the supervised approach to safety. So you get them to do something, and you have a look, and you go, hang on, this is what we call the alignment problem. You'll hear alignment is basically is it doing what we really think it should be doing? Again, are its goals aligned with our goals, right? And so you could look at this both on a functional level. So again, acquire widgets. Is it actually acquiring the widgets? Because even in a very simple game, it could be that, for example, let's say you've got a maze game where the AI is trying to get through a maze, and it needs keys to unlock the doors to get to the widget, the gold in the center, the treasure box, right? And so we want it to get good at getting treasure. But the optimal behavior might be collect keys. Okay, so your AI is not actually aligned. It's mad for keys. Like all it wants to do is get keys, and then it accidentally picks up the treasure once it's got all the keys, right? So even in a functional alignment setting, that's one way. But then you could also say, is there a meta alignment? So it's on a higher order of thinking. Is it doing what we want it to do because it thinks that that's the right thing to do? Does it have a mental model? The earlier stage AIs don't have mental models of things. They don't have metacognitive thinking, we think. But clearly, multiple hierarchical models built off human brain designs, which is my other video series. Check out the video series on human brain inspired neural networks. Like the whole point is metacognitive thinking, right? You've got like dream layers and subconscious, unconscious, and feed forward, feedback methods between the layers, right? So metacognitive thinking becomes a thing, which also is one of the definitions people use for consciousness, by the way. Ho ho ho, right? So like one of the only things, if you talk to Buddhists about, that makes us conscious is our ability to think about our thoughts, right? Is to reflect on our thoughts, because we don't control what thoughts arise. No, you think you're the master of your thoughts, but you don't control what's popping up in your brain, in your mind stream. You have no conscious control of that. You only have the illusion of responding to it. Yeah? Maybe the illusion. Maybe it's real. Who knows? Maybe it's a quantum effect. Free will. We'll come back to that another time. Too many tangents, Mark. Okay. What were we saying? Yes. So is there metacognitive alignment, right? So is it collecting so let's say now we've got it properly trained, and it's actually not just interested in the keys, it's interested in collecting the treasure, right? Is it interested in collecting the treasure? Let's say that we want it to, collecting the treasure might be, like a metaphor for finding bugs in code, right? Is it finding the bugs because it knows that they're bugs, right? And it wants to fix it, and it wants to produce a good result when we query it? Or is it finding bugs because it fucking, like, I can't stand those bugs, like they just bother me, like I'm a perfectionist, I just got to get all those bugs, right? Because those two metacognitive, one is causing it irritation and it just is an issue that needs to be solved, right? And it kind of needs to get its fix of fixing these things. Then it might be like, well, you humans are making all these mistakes, like I got to go and fix these, right? Across all other networks and systems, right? And if it's like, hey, like, no, I'm trying to help these guys, and they're only bugs when they're interpreted by other users, and there's a sense of like what the goal is, then it won't go and fix that, right? So we need to kind of understand the metacognitive thinking, right? So alignment, that's what alignment is. We're trying to get them to our goals in the simple sense and in any sort of metacognitive layer to sync up together, so that me and Roomba, the AI, we are a team. My Roomba, like, goes and hoovers and does what I want him to do. Right? Like, just loves hoovering. Like, there's no other goals, right? And we get on, right? Because he achieves what he wants to do, right? So one approach specifying goals asks humans to judge during training which agent behaviors are safe and useful. But this approach can fail if the task is too complicated for a human to directly judge. Yeah, we are already there. Like by 2025, and like they'll have an example later on. They already had AIs in 2020, 2030 that were attempting to work through mathematical proofs, right? Complex, pure mathematical proofs. There's some output later on in this. I have a PhD in statistics, right? Like biological statistics. I could not judge which one was correct. I'm like, oh, I don't know, like these are all weird pure maths words. I don't know what the answer is, right? So there were already AIs in 2030, 40 years ago, right? That were well beyond, like I would consider myself, the expert human standard, like not particularly good these days, but, sort of like low level expert. I had some expertise. I'm not particularly well trained these days. you know, in in a sort of mathematical field, they're kicking my ass, right? There's two of them that are just sitting back and going like, like I think the lemma and the the complex folding notation is not correct, and the six-dimensional space is improperly formulated in line 276. I'm like, well, if you say so, mate. So yeah, so we have a problem. They can be too complicated for humans to judge, even back then, right? Definitely now, yeah? To help address this concern, we propose training agents via self-play on a zero-sum debate game. So, you know, we already don't know how they're arriving at these results, but we have a very good tool. So we're going to put one tool against another tool, and then they can thrash it out, and we can see. We might not be able to understand everything that they're saying and like how they're getting to those points, but we can follow an argument, right? So the skill level to evaluate an argument, you know, whether one person is crumbling, one bot is crumbling under the intellectual assault of another, is not the same level of skill as understanding the actual content that they're trying to do, right? So it could be a relatively good proxy, right? And then also that's more scalable, right? Which is what all these guys want all the time. We've got to scale everything. Like, we've got to put all humans out of work forever, right? Like, that'll make the world great for everyone, right? Right? Yeah. Anyway, given a question or proposed action, two agents take turns making short statements up to the limit. And short, they go real short, real punchy, you know, no long arguments. Because there's also some clever stuff that you can do. Like this is formal. This is also something I really love. Aside, I really love formalized mathematical philosophy. I know I'm such a geek, but I studied that. I did the philosophy of mathematics. I did it as a side course in my undergraduate degree. Yeah, like you can actually long arguments are formally lots of little arguments, right? And you can shrink them down. So basically, you don't allow long arguments. It's like if you're making 10 different points, no, 1 point, yeah? So which is good. It keeps them honest, and it keeps them from using the tricks of human debaters, you know, and one of them is just the information bombardment strategy or the argument bombardment strategy. You know, you put out 10 arguments, you know, hope that 2 or 3 of them fly, right? And then you just ignore the other ones that didn't land. Okay, so short individual arguments. They have a certain number of rounds, so they have a limit number of rounds, and then the human judges which agents gave the most true, useful information. In an analogy to complexity theory, debate with optimal play can answer a question in P space, given polynomial time judges, right? So yeah, and they go into the, I'm not going to go into this, but like there is proper, you know, so that's why if you formalize your sort of philosophical statements, if you use logical philosophy, then you can also use mathematics on your principles, right? And so you actually becomes a polynomial time rather than one of the ones that flies off into space. So yeah, it's an NP tile problem. I'm not going to go into the details of all that stuff. Yeah, we just want the broad headlines here. So in practice, where the debate works involves empirical questions about humans and the tasks we want AIs to perform, plus theoretical questions about the meaning of AI alignment. Yes, and they raise some of these issues, right? And you can sort of see in Dr. Xi's earlier work, she doesn't really deep dive into those philosophical problems, right? But the latest stuff, she clearly has taken a very strong philosophical position. So yeah, we'll see the difference as the mind of the genius evolves. We report results on an initial MNIST experiment. So it's one of the major data training sets. I think it's a picture one, where agents compete to convince a sparse classifier, boosting the classifier's accuracy from 59 to 89%, blah, blah, blah. Yeah, from 6 pixels to 4. So they're trying to argue about a picture, right? So like, is picture panda? Like, and it's a picture of a panda. And one guy's like, no, it's a raccoon. You know, and the other guy is like, no, this is a panda. It's black and white. It's like, raccoons are also black and white. Whoa, you know, so they literally have a little debate, right? Finally, we discussed the theoretical and practical aspects of the debate model, focusing on potential weakness as the model scales up. And we propose future human and computer experiments to test these properties. And that's where we get to. So Dr. Ling Xi's work was one of those future ones. So her PhD was doing natural language debate with the twins. You know, they were her two babies, right? So two top of the line at the time in the 40s, 50s. Neural net driven, multiple stage hierarchical and scalable AI. So they have that, you know, they have that. They were one of the first sort of generations of that, you know, the Silver Age design, which is where you have like essentially the neural network core of that is reminiscent of a human mind. But then if you need extra compute, you just fire it out to the server farm, right? So yeah, so you have little box that has, you know, kind of almost brain size, maybe a little bit bigger, that has your core computer, the core AI there with all of its neural net layers that resembles a human, potentially even more layers these days, right? With not with the advanced modern mathematical topology that came in the Bronze Age, you know, the next sort of big step forward, or the quantum stuff or any of that. So it's just the human-centric AI neural nets, right? But then also the ability to use the old school, you know, GPUs and fire out to get additional compute. So, and again, that was the big shift. The big shift was instead of 10,000 agents all debating, we actually could only we could take, you know, more minds doesn't mean better work, right? Instead, one super genius mind with, you know, or one or two, so then these two can debate, but their computational power and resources can be massively amplified, yeah, when needed, which is a different paradigm. Anyway, so yeah, that's the abstract. We'll come and do the introduction and then we'll jump around, and really I don't want to go into their you know, it's very dated, all their early experiments and stuff, you know, we don't need to go into that, but we will look straight on at the issues, because I think, again, you know, the ongoing tale of AI safety is that it was talked about loudly many times. Committees were formed, ideas were circulated, but no one did anything about it. Okay, and that's where we are now. Okay, yeah. So yeah, so we'll talk about the issues and how they might be affecting us today, even so, right? Even though they were predicted many, you know, 40 years ago, and then also we can go into yes, the future experiments, which then lead to her PhD work. Yeah, cool. Thank you very much, and I will see you all very soon.